So for this syllabus point, for the subject advanced machine learning, linear regression and linear algorithms, we'll be referring today's content from this book by Jason Brownlee, Master Machine Learning Algorithms, discover how they work and implement them from scratch. So here it is speaking about gradient descent. Okay. So what exactly is gradient descent is? It is a optimization algorithm for machine learning. What it will be doing, it will be finding coefficients of a function. What is the job of those coefficients? They will be trying to minimize a cost function. Okay. So what the goal is, it is going to track different values for the coefficient, evaluate their cost, and select new coefficients which have a better cost. This is an iterative process, and each time it will lead you down bottom as in going down as in the gradient descent, as in slope. What is the procedure of gradient descent? There will be initial values for the coefficients, say 0, 0. The cost of the coefficient is calculated by mapping them to a function. The derivative of the cost is calculated. Once I say derivative, what I am telling you, we are finding the slope of the function at a given point. Slope will tell us what? The sign, the direction in which the coefficient values are moving. And this is lower cost as it is a derivative aspect. So this is how we are going down gradient descent. Once derivative is calculated, we know the direction, we know the sign. Accordingly, the coefficient values will be updated. To this, remember that a learning rate parameter by name alpha is added. What is the role of this alpha is? It will be controlling the coefficient changes for every update. This is an iterative process till the cost of the coefficient is 0.0 or no further improvements in the cost can be achieved. So this is regarding the gradient descent procedure. Now coming to our linear regression, we know that when I speak about learning a linear regression model, it means what? Estimating the values of the coefficient. Linear regression, the word itself tells us that it's a linear model. It assumes a relationship between input variable x and output variable y. The output variable y can be calculated from a linear combination of input variable x. If you have only one input variable x, then it is called a simple linear regression. If you have multiple variables of x, values of x, then it will be called as multiple linear regression. To prepare this model, linear regression model, the most common method used is ordinary least squares method. What exactly the linear equation does is, it will be assigning a scale factor to each input value, and that scale factor is called as a coefficient, and the coefficient is represented by the Greek alphabet beta. One more coefficient is added which gives us additional degree of freedom. What is this additional degree of freedom? This additional degree of freedom is actually the intercept or the bias coefficient. But with this, what is possible? Moving up and down on a two-dimensional plot. Moving up and down on a two-dimensional plot. You always see this kind of relationship in a linear regression, right? Y is equal to b0 plus b1 into x. So this is when we have a single x and a single y. But let us say we have multiple x's. Okay, the dimensions will be changing, and it will be a hyperplane, and the representation will be with specific values of b0s and b1s. When I say the complexity of regression model, actually I'm speaking about the number of coefficient used. When the coefficient is near zero, actually what it is doing is it is removing the influence of the input variable on the model. Next come regularization. Okay. What is regularized linear regression? Actually, they are the extensions of the training of linear model. What they will be trying to do, they will be minimizing the sum of square errors of the model, say using ordinary least squares, also reducing the complexity of the model. The two most popular regularization techniques are lasso regression and ridge regression. Lasso regression is called as L1 regularization and ridge regression is called as L2 regularization. What both will be doing, they will be modifying these ordinary least squares so as to minimize the absolute sum of the coefficients. How do I predict using linear regressions? Let us say this is the relationship y is equal to b0 plus b1 x1, where y is the weight and x is the height. It means x height is the input and weight is the output. It means what needs to be predicted? The weight needs to be predicted. Where b0 is what? It's a bias coefficient. And b1 is what? It's a coefficient for the height column. Now we need to set the coefficient values, good coefficient values. And post that we'll be predicting the weight. Coming to the heuristics, whenever I'm using learning the linear equation, the heuristics can be linear assumption, removing noise, removing collinearity, Gaussian distribution, rescaling the inputs. So this is in brief what I wanted to convey today. So I request you to